Okay, so this is that same question about the game of chance that we just looked at. So this question that we've already done about this game of chance, but this time we're asked it in a slightly different way. We're asked to find out how many games would Connor have had to have won for there to be evidence of his cheating. Okay, and what this is called is finding a critical region. Okay, so a critical region. So let's have a look at doing this. So what do we want? We want to know then, and don't forget it was a 5% level of significance. We want to know at the 5% level of significance, so starting at no games and ending up, because there's 10 games altogether in that sample, at what point would we say, do you know what, there's evidence now at this 5% level that there has been some cheating going on. So I'm just going to put some arbitrary point on here, and I'm going to call that value C for critical. And what I want to do, I want to find that value C such that the probability of being greater than or equal to C in this case, so this probability up here, what do I want? I want that to be bigger, I want that to be less than 5%. I want this to be at the very top end. I want it to be unusual. I want it to be a less than 5% chance of winning, so less than 0.05 as a probability. So that's what I want to look at, because then if I'm in here, if my probability of winning that many times is less than 5%, I can say that's not very likely at all. And so there's evidence there to support Linus's claim to say something's changed with the probability, and the probability of winning's increased. Okay, so let's have a think about this. So what do I want? I want the probability that X, the number of games won, being greater than or equal to some value C here. I want that to be less than or equal to my 5%. So that's what I'm looking for. I want it to be less than or equal to my 5%. And again, I'm going to use the binomial CD, but I'm going to use the list function because I'm trying to find out this value of X this time. So I don't know my variable. I'm going to have to try and find that out. But again, I can only do less than or equal to on my calculator. So I'm going to look at this. So the probability is up here. So I have to do 1 minus everything less than this. Now don't forget these are discrete. So because they're discrete values, there's nothing between this value and this value here. So what I want to do is to do 1 minus everything less than this. So I don't want that included. So that's going to be 1 minus everything less than or equal to this value here, which would be C minus 1. You know, so if this value is 7, this would be 6. If this value is 8, this would be 7, etc. Okay, I'm going to rearrange this. So take my 0.05 over, take my probability over, and what I'm ending up with then, and we've seen these sort of things before in other questions we did back in class, what I'm ending up with if I read it that way is I want the probability of X being less than or equal to this value C minus 1. I want that to be bigger than 0.95. So I'm going to do my list function on my calculator, and I'm going to have a look at this. So hopefully you can see this. So we're going for binomial CD again because it's a less than or equal to. I want a list this time because I don't know the value of my variable X. That's what I'm trying to find. And this one's only going from 0 to 10, so I'm going to just put them all in. Obviously, if it was a bigger value of n, you maybe do it in chunks and then use trial and improvement to get your value. So let's put these in. 4, 5, 6, 7, 8, 9, 10. My n, if we go back to my question, my n was 10. My probability of success is a quarter. And then here's my list. I'm not sure if you can see that very well, but here's my list here. And if I go down here, the first one that's greater than, I don't know if you can see that there, the first one that is greater than 95%, 0.95, is the value 5. Okay, so less than or equal to 4, 0.9218, less than or equal to 5, 0.9802. So that means that C minus 1, that critical value here, is 5. Okay, because the probability of being less than or equal to 5 is that we've just seen on our calculator, 0.9802, whereas the probability of being less than or equal to 4, let's say the one before that, was 0.9218. Okay, so what does that mean? That means my actual critical value is 6. So my critical region is x is greater than or equal to 6. So basically, if Connor had won 6 or more games, then there would have been evidence at the 5% level to reject H0 and to support the fact that Linus has said something dodgy is going on here, there's a little bit of cheating going on, the probability of success P has increased. Okay, the next example I'm going to do in the next video is a two-tail test.